Okay, so the first thing that I want to know from you guys, like whenever you're going to be defining the relationships in Java, right? There is something called a EJ relationship or something which is called as, inheritance. So you write different components in Java, which extends to another. For an example, there can be a couple of classes. There will be a parent class. For an example, there is a class called parent, and there can be a class called child. Okay, let's say there is a couple of classes like this is one class, this is one class. So let's say child class extends to parent class. How are you going to be defining that in UML notation? This is the class. This is how we create classes in UML. The first this part is the class name. This is where we'll creating the attributes of variable and we'll be placing it in this, and here we'll be placing our method name, and same for this class as well. So imagine this is something that I have created. Imagine I'll just give you some sample here. I will go to this test package and we'll create a sample class called parent, let's say. And imagine there is a class called parent and there is another class called child, like this class child. And let's say now the child class extends to the parent class, right? This is what we basically mean in inheritance, right? We're inheriting the properties from the parent in the child. So how are we going to be defining the same thing in UML? So now the child extends the parent, which is this one, right? So this extends to this. So the way you can define the same thing in UML, you can choose something called generalization. You just click on this, look at that arrow mark that we'll be giving from here to here. If I'll put it over here, this is what you mean by extending. So now by looking into this diagram, you can see the child is basically, see the arrow mark here to the parent, right? So the child is extending the parent, and this is how you'll be defining the extends thing in UML, right? So the thing that I have written here in code, parent, and we have a class called child, and the child extends to the parent class, and this is how it looks like in UML. Okay, hopefully it's making sense. Now for an example, we can create one more class, right? For an example, we can create another classes right here, and let's say this is child. Let's say this is a class called child1, and there is another class called child2. Okay, let's say there is another class called child2. So can the child2 class also extends the parent class? Is it possible in Java? So can we do like this? If I click on the generalization and if I give this notation, just see this notation, because in every UML diagram you're going to be finding this arrow. You can find a solid line with an arrowhead like this, and this is what you mean by child1 extends to parent, child2 extends to parent. In code, if you want to show it, like it's going to be like this, class child2 like this, and this is going to be child1 extends to parent, this is going to be child2 extends to parent. Okay, I hope this is making sense to you, and the same thing that I have defined over here in the star UML. So basically just understand this much, is that whenever somebody says generalization as a relation in UML, that basically means inheritance, and here the child1 and the parent has a relationship, and the child1 extends to the parent, right? So parent is a general version, and child1 and child2 are two different classes which basically inheriting from the general version. For an example, you have a class called account, which is kind of a general version, but there are two different kinds of account called current account and saving account, two different component extending to the account. So account is a general version, but current account and saving account are basically extending, inheriting the properties and giving it own feature kind of a thing. Okay, so before we go for the next thing, which is the interface and how to define interfaces in UML diagrams, I want to ask you one more question. Is this thing possible? And let's say I'm gonna delete all these arrows and I'm gonna give some arrows like this. And I'll click on generalization, I'll give an arrow like this. So is this a right kind of UML diagram that we have? Well, the UML is already allowed me to write this kind of diagrams or to create this kind of diagrams. But let's think about Java. We are Java developers, right? So is this things is really possible? What do you mean by this thing? There is a class called parent. There are a couple of classes called child1 and child2, and the parent class extends to the child1 and the parent class extends to the child2. You can see parent to child I'm reading because the arrow mark is on the child side, right? The arrow mark, the arrowhead is on the child side. So I'm just reading like parent extends to child, parent extends to child 2. So is this things is really possible? So basically if I'll show it in code, it will be like this. You have a class called child1 and you have a class called child2, okay? And the parent is basically extends to child1 and child2. So child1 comma child2, right? This means that. So this particular diagram that you are seeing is basically means this. So is this things is really possible in Java? And obviously, you know, this is something what we call multiple inheritance, where basically meaning by writing this is like, you know, parent class is extending both from the child class 1 and the child class 2. That's what I'm defining right here by giving a comma. But this is not possible in Java because multiple inheritance is not supported. So this is something about generalization you got to remember whenever you are dealing with multiple classes and the generalization or the inheritance thing. One more thing I will tell you, like you can see right now, let's say the child 1 is having is getting the feature of the parent, and the child 2 is also getting the feature of the parent. Now, one thing I want to tell you to do and to keep in mind whenever you are creating any UML diagrams. So if there is a class called parent and the parent is right now extended by child 1, it is also extended by child 2. So if the superclass is extended by multiple classes, you can actually merge these lines, okay? The way you will be merging this line, you can click on this parent. I'm talking about star UML specific thing. You can do this in any of the UML diagram that you're creating in any of tool editor. But if you're using star UML, I can go to tools and click on merge generalization. If I click on this, you can see like this kind of diagram you'll see pretty much in your projects every day whenever you're talking to the architect or talking to your lead and you guys are discussing about something in a meeting hall. You'll be talking in this way and you'll be seeing this kind of diagram pretty much in your day-to-day coding job. So here I just have done the same thing, just made sure that I'm merging the relationship with this one arrow head. If you separate the arrowhead, it will look something like this. But the best thing you can do is basically always, if one class is extended by multiple classes like this, just merge the arrow like this. Okay, this is going to be the standard, and don't do it manually. Always use your the tool that you are using to create the UML in order to merge this thing. Okay, so why I'm telling you all this UML thing, why I'm not diving deeper to the Eclipse straight away, the project that we have created, we can go into that, and why I'm writing all this unnecessary stuff and giving you some time to understand all this thing is because we're going to be creating the diagram, the UML diagram for the code that you have written over here in the last session. In the last session, you have developed all this thing, the course management system, and I want you to create the UML for that. And it will be very easy to understand the OCP if you can create the UML diagram. So it will be so much exciting for me to introduce to that thing right now, because I know once you understand all this UML stuff, you can basically tell me, okay, Vilas, this is something that you can do next. So yeah, so let's see the next thing in the UML. So the next thing that I'm going to be talking about how to basically define interfaces. For an example, if I'll remove all these classes right now, there is no need of this, so I can just simply delete this parent class because I'm done with this. So if you remember, in the last session we have created an interface called course. This is a simple interface having no methods inside it. Right, so it's an interface, and the interface has different implementation. For an example, if you'll go to the Java class, you can see the Java class implements course. If you go to the Hibernate class, then the Hibernate class basically implements course. If you go to the microservices class, microservices is also a type of course. And also if you go to the Spring Boot class, the Spring Boot is also implements course, right? So all these things like Java, Hibernate, C, microservices, all these things are implementing an interface called course. So the course is basically the root type or the main interface type that we have. And if I do a control T here, whatever the classes which implements course is basically right here. So the main root type is in a course, and then there are different classes which basically implements the interface called course. Like a class called Java is basically implements course. So there is no method inside the course, so there is nothing to override right here in the Java class for now. But yeah, it has some methods which are its own method, like do registration if somebody want to do a registration for Java, and also it is also giving the course content, or it's printing the Java course content if somebody is calling this method. Whatever, I don't give a damn what is written over here. I just want to tell you that if you have a interface called course, and if you have a class called Java which implements course, just look at this line. No need to watch this code. Just look at this line, Java implements course, how you'll be defining that in UML. So it'll be very simple. So what is going to be our interface? So the interface, the way we can create, you can click on this interface and then you can create an interface right over here. And this is something we can call like, course, right? Like this. So this, circle defines an interface in UML. You can also define some UML like your class, right? If you see a class, if I create a class like this, you can see how the class is looking like. This is the class name, and this is the variable segment or the attribute segment, and this is the method segment. Like that, in interface also you'll have methods, you'll have variables, and you'll have an interface name. Right now this course is my interface name, but where I can specify variable, okay, it's not visible over here, right? If I create any variable, add and attribute, and if I give an attribute name, so see, like, there is nothing coming here. You can see there is something called course, and right here only attribute 1 is coming, like, the attribute that I have added. Let's say I'm changing the attribute name to, let's say test, right? So now I am not able to see the test variable right here. If you see in the class diagram that I have, if I click on add an attribute, the attribute is coming directly right here, and right here I can just write test like this, right? So now why this thing is not coming here, and in order to get that in star UML, you can click on format and click on stereotype display and click on label. Okay, now you can see something like this, like a class diagram. You have a tag here called interface, and course is your interface name. But where is the attribute that I have created? If I click on this course, you can see the course has an attribute called test here. You can already see, but I'm not able to see it over here because it has been suppressed. So you can click on format right now, just uncheck this suppress attribute. Okay, now I can see something here called test. You can change it to something else called XYZ or whatever variable name you want to give, and this plus defines your public, and obviously the interface variables are public. So obviously in my case, in my Eclipse, the course that I have, which is the interface, does not have any variable. Okay, so let's say for now I'm just removing the variable from here. Okay, like this. And also the test one also, I'm going to be removing the variable. Let's say I have a simple class right now and a simple interface here called course. Let me change the class name to Java. Let's say this is something that I have here in my Eclipse. Now course has an implementation called Java. If you're going to click on this, Java implements course, right? Perfect. So Java implements course. Java is a class which implements course. Now how I'll be defining that? Right now I have an interface, I have a class. Now how this class called Java will be connected with the course? How I can show it in UML? And like the inheritance, which is called generalization in UML, Like that in UML, the inheritance thing has been termed as generalization. Like that, if you talk about the interface thing, and if a class is basically implementing an interface, then this relationship is called realization. Okay, so basically to define the interface implementation thing, for example, Java class implements the course interface. If you want to show this in UML, you can use this this guy, interface realization. Click on this and you drag like this. Okay, so this is something that you have. This is something the relationship which is going to look like. So if you're going to see like our Eclipse code, we have a class here called Java which implements course. Course is an interface, so course is implemented by Java. Same thing that I have defined here, course, and this is Java. And now you can just basically provide different methods. Right now, if you can see the Java class, if I go to the Java class, it has a couple of methods called do registration and get Java course content. And both of these things are giving me string and they are public in type. So you can how to create methods inside the Java class, right? You can click on add and operation, and you can start adding operation. And the first operation name is do registration and it returns a string. And let's go to star UML. You can just do registration, and this method takes nothing and returns a string. There is a plus sign here, and this is a public method. Create another operation, and this is like get Java course content. This is the method that we have. It also returns string, and it is also a public method, so click on plus. Okay, so right now if you're going to see do registration, return string, get Java course contents, return string, that's something that we have over here. Get Java course content, return string, do registration, return string. Okay, and Java implements course. If you're going to look all this class that we have, the technical diagram or the class diagram of this in UML is going to be this. Hopefully this is making sense and how you're going to be defining the relationship in UML. I hope this is making sense, right? Perfect. So now let's just go ahead and complete our different type of courses that we have. So if you're going to see right here, like Java class implements course, we have Hibernate class which also implements course, having a method called do registration and get Hibernate course content. And like that, you have a class called microservices, having a method called do registration, and also having a method called get microservices course content. And also we have a different type of course called C, which also implement course and having certain method called do registration and get C course content. So how to define all these classes in our UML diagram, and just notice that all these types that we have, they all implements course interface. So Hibernate, microservices, all these courses is basically implements the interface called course. And if you're going to define the same thing in star UML, so how we can do that? Let's say there is one type here called Java, and can I just maximize it a little bit? And there is another type that we have, another class we have, and this class is called let's say Spring Boot. Okay, and also the Spring Boot class having a inheritance realization with the course interface. Now this is how we can define, like Spring Boot is also implements the course. And now if you're going to go to the Spring Boot, okay, it has a couple of methods called do registration and get Spring course content. Let's just create all these operations like that. Now let's just go ahead and create all the type of courses that we have in our application. Perfect. So right now we have an interface here called course, and we have different implementation for this specification called course, like Java, Spring Boot, C, Hibernate, and all these things is implementing the interface. And the way we're going to be defining interface is by using this dotted line with a arrowhead like this. Okay, so I think this is making sense. Only the difference between the inheritance and the interface here is that in case of inheritance we used to use a solid line, but here inside the interface scenario the classes is having a dotted line with a arrowhead like this to define Spring Boot implements course, C implements course, Hibernate implements course. Like that we have also another type here, I believe, called microservices. So the microservices I have not defined here because I'm just saving a little bit of space for you guys, so that in future whenever I will just discuss the problem, it will not be too much difficult for you guys to understand this thing. So I hope we are ready right now. So now let's just understand the next thing. And the next thing here is that if you're going to see right here in our application, I have written a class here called syllabus printer. And the syllabus printer is a class which basically having a print method. And the print method is taking a course as a method parameter and doing certain operation, and the based on the course type that we are giving, like Java, C, Hibernate, Spring Boot, microservices, or whatever, is basically doing a print content. It's basically printing the content or printing the syllabus of that particular course. Basically the things that we are doing inside this print method is just like printing the course content of that course. So basically how we can define this print method and how we can define the syllabus printer in our UML diagram right here, and how the syllabus printer is going to be linked with all these classes and all this design that we have created. In order to basically go ahead and define the print method and the syllabus printer class in the UML diagram, before you create this thing, you got to understand one more concept, and that is called the difference between association and dependency. There are two different terms. Right now we discussed about the easy relationship, which is basically the inheritance in Java. Like that in object oriented programming we have also concept of association, and also we have a concept of dependency. So let's just talk about that a little bit, then we can come to this diagram and we will just complete it. So I'll just let it right over here. Maybe I'll save it first. I'll name it like our course management, so I don't want to lose the progress that I have did here. And I'll create a new maybe a new template here. So right here, first of all, I want to discuss about the topic called association. What do you mean by association in object-oriented programming? So before I do some coding and let you understand about this thing, so imagine you have a class here. This class is called YouTuber or something like that. And you also have a class here called subscriber. Okay, all the YouTubers will have hundreds of thousands of millions of subscribers, right? So let's say subscriber. Okay, so there are two classes. One class is called YouTuber, one class is called subscriber, right? So do you think these classes that we have, YouTuber and subscriber, these classes right now, looking into this diagram, do you feel is there any kind of relationship is there in between them? No. If you want to show this diagram to any kind of developer in the world, what they will do, what they will just create out of this UML diagram is going to be very simple. They will go to their favorite IDE. Let me close all these classes and let's just go out of this the project for a moment. And let me just go to my test package and let me create, let me just define the same thing that I have done in the UML. I will create a class called YouTuber, and I will also create a class here called subscriber. Create a class, the class will be subscriber. Okay, and I'll create a couple of classes here, YouTuber and subscriber. These are my classes that I have created, and this is how it is going to look like. Okay, so out of my UML diagram, I created these two classes. Do you think when you see these classes, do you think you have any kind of relationship between these classes? Do you think the YouTuber knows the subscriber or the subscriber knows the YouTuber in this case? No, it's like, you don't know me, and before you find me, I like you also like, let me just tell you that it's like I don't know you, and before you watch this video or before you found me on YouTube, you also don't know me, right? You didn't know me, I also don't know you. It's like some kind of situation, right? These classes are not related or they are not associated with each other. They are not linked with each other. They don't know each other. YouTuber does not know subscriber. Subscriber also does not know YouTuber. Why I'm saying that they don't know each other? How I can make this YouTuber class or YouTuber to know a subscriber, and how the subscriber I'll force them to know the YouTuber, how to do that? And to do that, we need to make sure that these classes are in association. And the way I can say, let's say the subscriber knows about the YouTuber. Let's say in order to do that, I need to do this YouTuber. Okay, I'll create a reference variable, and by doing that I'm telling that the subscriber is right now knows the YouTuber. The subscriber is basically using the YouTuber. The subscriber can navigate to the YouTuber by using this YouTuber reference, and this thing, guys, is called association. Okay, so what do you mean by association? Association means in a class, you're going to be having a reference of another class. So this is a class, this reference I'm going to have it over here. Now in the UML diagram, if you're going to see the UML diagram of the subscriber, which is this one, the subscriber is right now knows the YouTuber. The subscriber is right now having a reference of the YouTuber. And in order to define that, you click on this add here and click on an attribute, and this attribute is going to be like a reference variable you have here called YouTuber. This is the variable name, and it is like the type is YouTuber, right? So this is the variable that you have, and now the subscriber knows the YouTuber. The subscriber is having a reference of YouTuber. And now the way we can define right now the subscriber knows the YouTuber, if I can define it, there is something called a directed association. You can see I can just click on this and leave it over here, and look at that, this arrowhead that I have. Okay, if you can see this is a relationship that the YouTuber and the subscriber is right now having. Now it is saying that the subscriber knows the YouTuber, but does the YouTuber knows the subscriber? No, the YouTuber does not know about the subscriber because it does not have any subscriber reference here. So if I'll go here, and if inside the YouTuber also, if I'll say, let's say you know me, okay, and let's say I also know you, then let's say I can just do subscriber. Okay, now what it does mean that YouTuber also knows the subscriber is also knows the YouTuber, right? So now if I'll go to the star UML, and here inside the YouTuber also I can just give a variable right here. In this case, this is going to be subscriber is going to be the type, and the variable name is here is called subscriber. Right, subscriber is the variable name, and subscriber is the type. Now in this case, this arrow that I have given, it should be double headed. So in this case, this arrow will be double headed. I can give an arrow here also. So now the YouTuber knows the subscriber knows the YouTuber. But in my example, I don't have this one. I have only the subscriber who knows the YouTuber, but the YouTuber does not know the subscriber in this case because it does not have a reference variable. So this is an example of an association. Now the subscriber class is associated with the YouTuber, and this is This is the arrow by using what you can basically give and direction, like you can navigate from subscriber to YouTuber. You can navigate in this way. What I mean by this navigation, the navigation mean, guys, you can see right now what I mean by this. The line that I have here, you can see this line is like, left to right. You just see it like this. Subscriber from this side, I have it to this side. That means I can navigate from here to here. But can I navigate like this? Can I navigate like this? If I'll remove this, can I click on, directed association? Is this correct? No, this is not correct. Why? Because the YouTuber right now is not having any association with the subscriber. You can see I don't have any variable here for subscriber. So the YouTuber class, the line right here means that from the YouTuber, I can navigate to subscriber. But looking into this, I don't have any reference variable of subscriber here. So this is wrong, but this is right. This is right. Okay. Why I'm telling that? Because here I have a variable for type YouTuber. So from here, from the subscriber class, I can navigate to the YouTuber class using this variable called YouTuber. So I'll show you how to do that quickly. Okay, so now that we understand how to define association between couple of entities or couple of components in UML, and the association can be a solid line without a diamond shaped arrowhead. It's like a normal arrow, not a diamond shaped arrow like inheritance or interface, examples that we have seen before. So now let's understand why I'm calling this is a navigation. Using subscriber, we can navigate to YouTuber because the arrowhead to this side, to the YouTuber side. So we can navigate from here to here. Why I'm telling this, what I mean by that. So let's just practically understand about it. So subscriber is going to be here. Let me just move the subscriber to this part, and let me move the YouTuber to this part, just the way it is in our UML. So now what I said, now the subscriber has an association dependency with the YouTuber, right? So subscriber and YouTuber, let's say for now the YouTuber does not have the subscriber here, so I only can navigate from here to here using this guy, right? So how I'll be doing it to make you understand that, imagine I have another class here, let's say new class, let's say something called test, and let me bring the test class to, okay. Let me just open the test class first, and let me just move it to this side. Okay, let me collapse everything. Now imagine you have a main method. Okay, now using this main method right now, let's say you are creating a subscriber object right here. Now using the subscriber object, you can also initialize this YouTuber reference here. How you can initialize this reference when creating the subscriber object? Maybe you can use a constructor, or you can use a setter method to initialize this. For an example, you can just have a setter method or constructor. I can just create a getter and setter, or maybe a constructor I'll just straight away create. I can click on source and generate constructor using field, click on generate, do a generate. So you can see I have a constructor for subscriber. So whenever I'm constructing the object of subscriber, I can take this object from the client who is basically using the subscriber object, or who is basically creating the subscriber object, and I can ask him to give the YouTuber object, and I can initialize to here, to this variable. And the way I can do it in the test class, you can see whenever I will be creating the subscriber object, so I can just do subscriber and subscriber is equal to new subscriber, and I can just give a YouTuber object, let's say new YouTuber or something like that. In the parameter only, whenever I'm creating the object of this object of the subscriber, I can do like this. And in this way, I'm using the subscriber, I'm giving the new YouTuber object, it is going to here, and I'm basically assigning it to this .YouTuber. So now this basically becomes is equal to new YouTuber. So using my client class test, I'm basically initializing the subscriber, and while initializing, I'm basically giving the YouTuber object, right? And you can see right now, I'm creating the object of subscriber. I'm creating the object of this guy. But right now, using the object of subscriber here, I can navigate to the YouTuber class. For an example, the YouTuber class has a variable here. Let's say it has a variable here called private. Let's not make it private. Let's say string channel name. Now let's say if I want to do something, I can just use this subscriber object right now. I can just do subscriber, okay, dot YouTuber, because see, subscriber class is what? This one. And inside this object, I have this YouTuber. And using this YouTuber object right now, I can navigate to this class and can access this variable and can change it. Okay, so you can see subscriber.YouTuber.channel name is equal to Selenium Express. Okay, now see what I have done. I am navigating, right? I am doing the navigation from the left side to the right side, from the subscriber side to the YouTuber side, from here to here. How? Using this variable. Okay, so this is the reference that I have inside the class called subscriber, which is called the association. The reason why I'm calling it association, because it is a reference object that I have inside a class, and this is helping me to navigate to the YouTuber class. And this is how I'm creating the object of the subscriber, then accessing the YouTuber variable right here, and then going inside this YouTuber object, which is this object, which is this class here, and accessing it variable and assigning some value to that, right? Now I can also print it, right? If I'll do sys out, and if I'm going to print this thing, it is not going to be null right now. It is going to be whatever I set here. Let me not put it inside the string. And if any problem here, create constructor of subscriber. Okay, I think I have not saved it. Let me just run this Java application. There you go, Selenium Express. So you're setting the Selenium Express YouTube channel name using the subscriber and using the YouTuber reference here. I think this is making sense. This is what you call association in UML. If you understand this thing, this is an example of the association relationship in UML. It's like, one class need to have a reference variable of another. Using that, it can navigate to another class. Okay, so this is the example. Now subscriber is a component having a reference of YouTuber. So subscriber knows YouTuber, subscriber uses YouTuber. This is the relationship arrow mark that we need to understand. And this time the navigation only can be possible from this side to this side. And that is by using this variable called YouTuber. If I want, I can also put the subscriber reference here, and that will be bidirectional association at that time. And also at that time, this arrow mark, if I'm putting the subscriber reference here as well, then I can change this arrow mark to both end. Like the arrow mark can be here as well. Okay, because I can navigate from subscriber to YouTuber, YouTuber to subscriber. I think this thing is clear. Now let's go for something called dependency in UML. Okay, so now let's talk something about called dependency. So we learned about association, and now we'll be learning about another type of relationships that we can have between components or entities in UML, that's called dependency, and how we can basically define dependency between classes in UML. So what do you mean by dependency in object-oriented programming? Okay, we understand about association. I told about, like, if there is something like a class has a reference of another class, that's something we can call as a association. So a lot of people have a misconception is like, the association and dependency are exactly same, but it's not. The dependency is something a little different. It's similar to that, but it's a little different, and it's going to be very easy to understand right now. So let's just understand what do you mean by dependency in object-oriented programming first. So imagine you have a couple of classes. Let's say this is one class. this class is, let's talk about a class called player. Okay, player. Okay, maybe a game player. Okay, which kind of game he's playing? Ludo. Ludo game. Nobody will understand Ludo. Okay. Okay, in India you'll understand, but I don't know if you play that, in your country. But yeah, let's talk about a game called baseball or cricket. Okay, I think cricket or baseball, if you are not familiar with cricket, you can think about baseball. Okay, so in cricket, let's say there is another component here that we have called cricket. There are two components. One is called player and one is called cricket. Okay, let me make it cricket game so that it will be a little more easier to understand. Like, we have couple of component. One component is called cricket game. One component is called player. Now let's just go ahead and start creating a relationship between the player and the cricket game. Right now they don't have any relationship, but right now, how to create a dependency between them? Let's say the player has a dependency of the cricket game. How you'll be defining the dependency? Same thing, you just need to click on this dependency, but this thing is going to be different. See, if I'm going to put it over here, now the player has a dependency with the cricket game. The way I'm knowing that this is a dependency, by looking into this line. The previous one that we have used is called association. The association is having a solid line with the arrow mark which is not diamond shaped, right? This means the player will have an attribute of cricket game. The player will have a variable of cricket game inside it. But right now, dependency means what? If I say the player has a dependency of cricket game, how you will be defining that in code? So in code, it will look something like this. So imagine if I'll go to my test package, I'll create a class here called player. Okay, and let's say this is a component, and let's say I have another component here called cricket game. So cricket game. Okay, so now I have couple of components here, player and cricket game. Let's say in this UML diagram that I have created, it says the player has a dependency of cricket game. What I do mean by that is the player will have a method inside it which can take a parameter of this particular component called cricket game. Because the player is dependent on cricket game, that means the player class is basically having or is basically using the cricket game class. And if the cricket game class will be modified, then the player class will also be impacted. I'll tell you what I exactly mean by that. So the player is a component. So here I have created a class called player. If I will say the player has a dependency of cricket game class, then it will be like this. Imagine, let me just write something over here. Imagine inside the cricket game class, you have a method called, void play cricket, right? Let's say something like that, or let's say do batting. Let me just create a method called do batting sys out. Okay, player is batting, something like that. So a do batting method is inside the cricket game. Now imagine the player want to use this method called do batting. So if the player want to use this method called do batting, then they have to create an object of cricket game. But if I'll create an object like this, cricket game, it will be like association, because I have created a reference variable over here. But I will not do that. In dependency case, what will be there? It will be a method like this, public. Let me just not write public. The method will be public. Let's say void, let's say start game or something like that. If you want to start the game, which game you want to start? You want to start the cricket game, right? Then you need to accept that object as a variable. You have to take the object of the cricket game here in the method parameter. It will be like that, cricket game. And this means this method is saying is that to start the game, you need the cricket game object, or you need this class object. So in order to use this method, you need to have an object which is of a cricket game component. or which is of this class, which is a different class. And now the dependency of an object we have in form of method parameter, not in form of a method reference. Previously in association case, we used to have like this, cricket game, right? This is association. But now as we are basically, trying to accept the object, okay, through a different client class, or the person who will be calling that method, they will be giving us this cricket game object. And using this object, I can do anything. I can say cricket game dot do batting. You see what I did? If I want to invoke this method, and obviously I need to create the object of this class, I can do cricket game equal to new cricket game dot do batting. Then only this method will be called, right? So right now I'm only having the reference, and I'm expecting that the guy who will call it in the runtime, they will be giving me that this object, and using this object, I'm just using this reference, I'm calling this do batting method of cricket game reference, which is of this class, this method I'm calling here, right? How it will look like in real time. So if I'll open the test class, okay, let me collapse everything. Let me bring the test class to here. Let me remove all the subscriber stuff. I'll create a player object. Player is equal to new player. So the player object is created. I'll call the start game method of the player. So I'll do player. I'll use the player class reference dot start game. I'm calling this method. Now this method needs a cricket game object here. So I'll do new cricket game like this, right? I can save this thing. Now the error is gone. Now look at that. So whenever I'm calling the start game method of the player, now this method cannot be executed because it is needing a object of the cricket game. To execute this method, it is dependent on this particular class. So the player class has a dependency of this particular class. One of the player class method called start game is accepting the cricket game object in the runtime, and also it is calling one of the API method of the cricket game class, which is defined here. And this is a perfect example of a dependency. Okay, so I can define like this: start game. This is a method that I have inside the player. So I can go to my UML diagram and I can create an operation here, and I can say, what is that method name? And this is the dependency that I have from player to cricket game. Okay, so the player class is right now is dependent on the cricket game because it uses one of the method of the cricket game. Maybe here also I have a operation that is like, do batting, and this does not return anything. So this is a void one. So I don't need to define this one. Okay, so this do batting method, I'm using it inside the start game method using the cricket game object reference over here. So this is what I call dependency. The dependency will be always in form of method parameter. It's not always in form of method parameter. It can be also in form of method return type. For an example, you can think like this. There can be a method called start game. Maybe what I can do for now, let's say I'm just commenting the start game. I'm commenting the do betting in the cricket game. Okay, I'm remove the dependency. One more thing I want to tell you, the player also can be called as a dependency or having a dependency to the cricket game class if it is having any method. Let's say, start game. If you have a method like this, and to start the game, which game you are starting? Let's say the player will start the cricket game. So it will be starting the cricket game. That means it will be creating the new object of the cricket game. So I'm writing cricket game here. So I can see start game method is returning cricket game. Right now I'm not taking it as a parameter. I'm just returning it back. I'm returning another class object back. I'm returning this class object back right here inside the player class. So this is also an example of dependency. So right now here you can do return new cricket game, right? Right now this cricket game can be in form of return type or it can be in form of method parameter. Any of this example, if it is there, I can say the player has a dependency of cricket game. Okay, I can just give this dotted line here to define the relationship diagram, and to define that the player has a relationship with the cricket game, which is a dependency relationship, right? Player is dependent on the cricket game. Okay, forget about this method, I have commented it out. So now one more good example I can give why I'm telling like now the player is dependent on the cricket game. Imagine like the cricket game can be like for 5 days type. It can be played for 5 days. It can be played for 3 hours in form of 2020, or it can be played for the whole day in form of 50 overs cricket. There are 3 different types of cricket format: 50 overs, 20 overs, and 5 days cricket match. Okay, so let's say there is something called private string match type. Okay, let's say there are match type, different type of match type. Let me not make it private. Let's say match type, and the match type can be ODI, that's called 1 day international. It's going to be played for a day, or T20, it will be played for 20 hours only, 3 hours cricket, or it's going to be 5 days cricket. Okay, let's say this is going to be the match type. Okay, now in this case, let's say to initialize this match type, I'll have a constructor here right now. I have created a cricket game constructor here, which is going to initialize the match type. And as soon as I created this constructor, look here, I have a problem in the player class. Why I have a problem in the player class? Because I have told here only in the diagram, see, player is dependent on the cricket game. So any changes or any modification to the cricket game class may leads you to change the player class object as well, or the player class itself as well. And now we can see the player class is breaking because you have done some modification by adding a constructor and adding a new variable called match type, and this method broke because it returns a cricket game object, but this is right now not working because you modified the return type of this particular method, which is the cricket game, because the player is dependent on cricket game. So right now you have to come and you have to define the match type here. Let's say ODI or T20, you can give any value over here, then only it will work. So it broke because we did make some changes here in this class. So player is dependent on the cricket game. Okay, the start game method is dependent on the cricket game because it is right now returning a cricket game object over here and using the constructor of the cricket game. So if any changes will be there here in form of the constructor, it may break the player class as well. And that's why I have mentioned here a dotted line to define the relationship as a dependency. Okay, I hope this thing is making sense, right?